Please open in your learning workbook to page 216, and we're going to complete example 3, part A. All right, so before we begin, the first thing I want to share with you is this example is completely worked out in your learning workbook, so you don't have to write anything if you don't want to. Everything I'm about to write has already been written in your learning workbook, with maybe one exception. At one point in the problem, the learning workbook skips a couple of steps. I'll be sure to point that out when we get there. Okay, so solve. 10 raised to the power 5 plus 2x plus 820 equals 49,600. This is a problem that is exponential of type 2, which means that it can be written in the form base raised to exponent equals base raised to exponent, where these two bases cannot be written as powers of the same value. And remember that exponential type 2 also includes the possibility that one of those exponents is missing. So it can be looking like this, or it could be looking like this. Either way would be type 2. All right, so let's go ahead and solve this problem. So the first thing we recognize is that what we have here does not match what we see. What we have is base raised to exponent plus something equals something. And that is not the form that we're looking for. But we can create the form that we're looking for with subtraction. So minus 820 on both sides. And that leaves us with 10 raised to the power 5 plus 2x equals, and I'm going to use my calculator for this subtraction, 49,600 minus 820 is 48,780. 48,780. Okay, clearly 48,780 is not a power of 10. All the powers of 10 end in nothing but 0, like 10 or 100 or 1,000. So what that means is we are dealing with very clearly an exponential type 2 problem. And the way we're going to solve this type 2 problem is by using a logarithm. Now, the first thing we're going to do here is we're going to take the logarithm of both sides. And because our base is 10, we're going to use logarithm base 10. So, taking the log of the left side, we'll have log base 10 of 10 to the 5 plus 2x. And taking the logarithm of the right side, we'll have log base 10 of 48,780. Now this is one of those times when I want to make sure that if you are writing on lined paper, you're putting all of these things in the proper place. The log and this 10 go in between the lines, this 10 is below the line, and this 5 plus 2x is above the line. Okay, great. Next thing we're going to do is we're going to use the power property of logarithms, and we're going to move this exponent of an argument to the front of the log. So we get 5 plus 2x in parentheses times log base 10 of 10 equals log base 10 of 48,780. Okay, so this right here, this last line, and specifically the one above it, are not written in your solution in your learning workbook. So if you're looking to supplement your learning workbook, maybe you want to write this down. Okay, great. Now, one of the things that I have taught you is that anytime you ever see a logarithm where the base is a number and the argument is also a number, you need to stop and ask yourself this question. Can that be rewritten as an integer? Remember, a logarithm is a missing exponent, and log can be written as EGOB. Exponent goes on base. So, what is the exponent that goes on base 10 to make 10? The answer to that question is 1. So the value of the missing exponent is 1, therefore the value of the logarithm is 1. So this giant red box is just the number 1. So now we have 5 plus 2x times 1 equals log of 48,780. Notice that I'm choosing to no longer write the base 10. I don't need to. When you see log without a written base, you are to assume that the base is 10. Okay, anything times 1 is itself, so I get 5 plus 2x equals log of 48,780. Subtract 5 on both sides. 5's cancel, and I get 2x equals log of 48,780 subtract 5. Notice that I do not do this subtraction, and the reason why is because the log argument and something outside of the log cannot be combined. And then finally, dividing both sides by 2, I'm going to get my final answer. Log of 48,780 subtract 5, all divided by 2.